I represent the team responsible for U.S. cybersecurity at the Five Eyes Summit. I'm just going to go ahead and walk you through the cyber operations risk management briefing. This is the oral portion. We've submitted a written portion of the briefing as well if you'd like to look into it in more detail after the presentation. Look at the agenda. First item is going to be the overview, and then we have software assurance. We're going to look at software security measures and evaluation mechanisms. And then the third item, we have software development lifecycle and software options. We're going to be looking at how exactly we're going to build security into the software development lifecycle and which development methodology is going to work best for the U.S. federal government systems. And then we're going to look at costs, and then mitigating software vulnerabilities, followed by supply chain risks and supply chain options, right? So we're going to look at the sort of security measures we need to put in place to ensure that our supply chain is safe. And then we're going to look at contract language and security concerns for the U.S. federal government at the Five Eyes Summit and in general. So let's go ahead and get started. So, in order to protect the U.S. federal government information systems and network from the risks related to supply chains, software development, and procurement, this risk management briefing will cover all of these issues in detail in order to provide our nation's Chief Information Security Officer and other stakeholders with the information they need in order to make well-informed and efficient decisions regarding cybersecurity. Assurance is one of the cornerstones of software cybersecurity, right? It's essentially the justified confidence that software functions as intended and is free of exploitable vulnerabilities. And this must be implemented at each stage of the development process, right? So the software development process should take into account the security requirements and protection profiles to meet international standards based on the Common Criteria Recognition Agreement in order to protect the federal government software and information systems. So what does that mean? It means that our software should be evaluated based on common criteria standards, right? The common criteria standards based on the common criteria validation scheme, in which countries all over the world agree on certain standards for software security. And then we take our software to go get audited and validated by this organization in order to whether it be our software or our supply chain partner software, we need to ensure that this software is fully secure and there are no known exploitable vulnerabilities in the software, and this is one of the best international standards that we can use. The team will ensure that security is incorporated into each stage of the development process and implement fail-safe defaults in order to ensure that access to every object must be checked for authority, in addition to separating privileges to eliminate a single point of failure, right? So we want to vet these supply chain partners, ensure that we're only working with other organizations that have the same level of cybersecurity, the same standard as the U.S. federal government. And we want to make sure that we have access controls in place. We want to make sure that we have fail-safe defaults, just so that if anything goes wrong, our systems are protected. All right, so when we're talking about the software development lifecycle and software options, we need to understand what the software development lifecycle is and what that entails. So if you go ahead and look at like this graphic on the right-hand side, you'll see the entire software development lifecycle, which is critical for developing secure software, right? This is essentially how software is developed. You begin with a requirement analysis, right? And then you move on to the design stage, the implementation stage, and testing stage, which is very important for cybersecurity. And after that, you have the evolution stage, or like what did we discover during the testing stage, and how can we use that information to improve the software product or fix bugs or add new features, right? All right, so that's the software development life cycle in a nutshell. And a concerted effort must be made in order to mitigate the vulnerabilities and potential cyber risks associated with software products, right? So when we're talking about software development, we also need to we need to look into which methodology we're going to be using, right? So based on analysis of various different software development methodologies, right? Various different software development life cycles, if you will. We found that the scaled agile method would work best for the US federal government for a number of reasons. Mainly because it emphasizes flexibility and scalability at the same time, right? So the US government would be able to incrementally develop software, which is important, especially if you want to prioritize security, because incrementally developed software means that at each stage of development, we have a chance to test the software, make sure everything's running fine, make sure, all the known vulnerability exploits are covered, mitigated, right? We get stakeholder feedback before we move on to the next increment. At the same time, this is the U.S. government. There's a lot of bureaucracy involved. And we need the software development process to be highly scalable, right? So instead of using a traditional waterfall model, um, using a scaled agile methodology instead in its place would give us the same sort of stability and scalability as the waterfall method. Um, However, we'll also have that flexibility and incremental approach we see in agile. All right, so let's talk about money, right? The costs. Employing a scaled agile software development methodology is one of the most cost-effective models, right? Why? Because you have like this huge requirements and design stage where you're figuring out everything you need, you're budgeting, um, you're figuring out how you're going to design it. You kind of starting things off more waterfall-like, right? And then as you move forward in producing the software and things come up and issues come up and maybe the requirements might need to change just a bit, we have that agile flexibility, where we can incorporate stakeholder feedback. Somebody saying, hey, this isn't really working. It seemed like a good idea at the time, but now we found this new potential vulnerability that we hadn't seen before. We need to incorporate this into the software development process. We need to make sure that we get um, you know that security measure in place, or we need to add this new feature. um, so uh, it is cost effective. It's very cost effective because you can budget pretty well, but at the same time you can you have some flexibility there. Maybe a certain feature is going to be too expensive. We can figure it out. We're agile, right? Okay, but the main the main thing that's going to um, you know influence the cost of a software development project is really what kind of software we're developing, or what kind of software we're using, right? Is it going to be internally developed software, right? That's typically the most expensive option. You got to pay programmers, staff, software testing, um, a lot of direct and indirect overhead costs. This is all coming out of U.S. federal government's checkbook. So it can be very expensive. It has its advantages for sure, but just talk about money, that's the most expensive option. Commercially developed software, um, it requires companies, or in this case, U.S. federal government, to purchase a license to use the software in addition to the maintenance fees that can range anywhere from as low as a few percentage points, like maybe 2%, or up to like around 20% or more of the total solution, right? So that's it's less expensive than internally developed software. But at the same time, it's still gonna, it's still gonna cost. This is we have to purchase the license. We have to pay the maintenance fees. We have to negotiate contracts, and that's expensive, right? So looking at costs, this is the second most expensive option. Third most expensive, or the least expensive option rather, is just to use open source software. Uh, now, uh, there are some hidden costs. Typically open source software is free, but there's some hidden costs in there associated with, training employees, or spending more on security, or buying additional access to the software features in the code, or, like so many different, there's all these costs that aren't really upfront costs. Um, and then we may add in, we may base the code off of, this open source, or base the software off this open source code, and then begin internally developing, a derivative of that open source software, right? So we might take something open source and then begin internally developing it, and that's going to, increase the costs as well. So it really depends on how we're developing the software, and and um, and whether or not we're really a part of the development process, or we're buying commercial software. Okay, so mitigating software vulnerabilities is a very important aspect of software development and software procurement. In order to mitigate software vulnerabilities, the software needs to be fully patched and up to date. Again, whether we're using commercial software, we're internally developing software, it doesn't matter. It has to be fully up to date. It has to be fully patched whenever patches are released. Otherwise, we're going to be vulnerable to known vulnerabilities, right? We're not even talking about zero-day attacks. We're talking about known vulnerabilities if our software is out of date, or if it's not patched when patches are released, or if we don't work on releasing patches in the case of internally developed software. So the team needs to perform a code review of proprietary software using automated tools like TestLink and Finesse in order to conduct a vulnerability assessment of the software code before it's, deployed or procured, right? And then the team will also use these tools to conduct penetration testing using sandboxed, SQL or LDAP injections, or buffer overflow attacks, and other software-based attacks, memory-based attacks, in order to evaluate the software security against NIST SP 800-95 and 800-44 standards, and ensure that the software is not vulnerable to known injection and memory-based attacks. It's also really important that we look at supply chain risks, right? So we've kind of covered the software related risks, but what about supply chains, right? What are supply chains? This is our network of business partnerships, right? Typically, these are international partnerships that involve a lot of different people, a lot of different organizations working together, which means all of these different people need to have access to, or need to be able to communicate with the U.S. federal government, even if they don't have direct access to our network or to our systems, right? As long as they're communicating with our network and our systems, even just our email servers, right? That presents a huge risk to the U.S. federal government, right? Having all of these different endpoints, all of these different partners accessing our network and communicating with us. So in addition to insider threats with legitimate access to the federal government supply chain, right? We also have this issue of criminals and hackers that pose a threat to the supply chain as well. According to a Resilience 360 study, there were nearly 300 cybersecurity incidents impacting supply chain entities in 2019. it's a lot. It's a lot of incidents, especially considering the scale of supply chains. So one weak link in a supply chain, like a malicious group of employees working together, um, or working for another company in the supply chain, or a company that has poor security practices can pose a major risk to the supply chain as a whole. So essentially, companies are only as secure as the most susceptible stakeholder in their supply networks, right? So, you're as secure as your weakest link in the supply chain. And if you're part of this huge international supply chain, it's coming in and out of different countries, all kinds of different security standards, that just poses such a huge risk. Mitigate these supply chain risks, right? And what are our options regarding supply chains and our business dealings with this huge network of companies all around the world, right? How do we handle that? So, in order to improve the federal government's supply chain security, third-party supply chain vendors or contractors working with critical systems and data should be monitored and recorded using tools like BlueSpur, for example, to track vendor activity with access controls compliant with NIST SP 800-12 standards put in place in order to reduce the likelihood of malicious activity. So we need monitoring, 24/7 continuous monitoring of any access into our network, data leaving our network. We should probably put in place, a data loss prevention systems, but we're mostly concerned about external threats to our supply chain. So monitoring is important, and then access controls, that are compliant with NIST 800-12 standards, critical to our cybersecurity when we're dealing with large supply chains. So the federal government should also conduct procurement and supply chain management processes according to the NIST SP 800-161 standards, which provide guidance in identifying, assessing, and mitigating supply chain risks at all levels of the U.S. federal government or any organization, right? So we don't just want to focus on access control monitoring. We also want to focus on supply chain security as a whole, and we need a standard. We're going to use the NIST standard, right, to measure our cybersecurity practices against that in order to ensure that we're covered. I mean, there's no such thing as 100% safe, but we want to get as close as we can to that. So the last item on the agenda is contract language and security concerns. So what are we talking about here? We're talking about the kind of contract language the U.S. government needs to use in its supply chain partnerships before for finalizing any sort of supply chain agreements, right? Before we're signing any ink, we need to ensure that certain standards are met. And a lot of these standards are based on the U.S. federal government cybersecurity concerns. So how are we incorporating security concerns into our supply chain agreements, right, and our contracts? So you go ahead and look at the table below. We have the federal government software requirements. There's a lot of different items here. I don't need to go through them all right now. There's a written portion of this presentation that has the same table and a lot more information than what I'm presenting today, but we can just go ahead and look at a few of them. The first two, the U.S. federal government retains the right to review and inspect the software product or service before formal purchase is made. That's really important, right? We need to ensure, right? We're not just going to take, the vendor's word for it. We need to ensure that, the software is compliant with our security standards, right? And then we also need to have access to the software source code in addition to the libraries and tool sets used to design that software, right? This is if we're purchasing commercial software. We go down the list here, a lot of NIST standards that vendors and business partners need to be in compliance with in order to work with the U.S. federal government. Um, One critical item near the bottom is that supply chain partners must not disclose any confidential, proprietary, or otherwise sensitive information acquired or learned from working with the U.S. federal government, right? And then, of course, you look at the last item here. All business partnerships need to be in compliance with relevant, international, federal, state, local laws, right? Um, and if we can ensure that all of these different requirements are met, software, vulnerabilities are mitigated. We're mitigating supply chain risks. We're incorporating cybersecurity into each stage of the software development lifecycle, or we're making sure that our partners are doing that. Um, then that this is how I would say this is the best way we can go about ensuring, um, the federal government's cybersecurity throughout the software development and procurement process, and in dealing with supply chains. Thank you.